So in this lecture, we'll be understanding the most important part of the chapter matrices, that is transpose, and what are the properties related to it, symmetric and skew symmetric matrices, what are the properties, inverse of a matrix, and the elementary row operations. Okay, the solved examples and the PYQ sections will be uploaded in the description and in the WhatsApp group. Okay, so do join the WhatsApp group for any doubts and for the regular PDFs updates and the question answers. Okay, so let's start with the transpose of a matrix. Now, what do you mean by transpose of a matrix? So very simple concept, students. We won't go much in depth, but I'll give you a clear idea. Understand it, very simple. A matrix which is obtained by interchanging the rows and columns. What is it? Matrix which is obtained by interchanging rows and columns. Now, a matrix A is given as A is equal to A of ij, and the number of rows is m and the number of columns is n. Now, the moment we transpose it, student, what will happen? The number of row will become n and the number of column will become m. A very simple example you can see. A matrix is equal to 1, 2, 3, 4 and 5 and 6. Okay. Now, the number of rows is 3 and the number of columns is 2. The moment we transpose the student, what will happen? The number of rows will change to what? 2 and the number of columns will change to 3. That's it. Okay. So what is happening in the transpose part is the rows is getting interchanged to columns and the columns are getting interchanged to rows. Very simple. How do we denote it? That is a bit dash, that is also, or A transpose. Both the methods we use it. Okay. Don't get confused in this. Okay. Now, coming to the property section, very important properties for the exam point of view, for your PUC part. Okay. So few properties are very simple. So the first, if you transpose one time and again transpose it, you get the same matrix. That doesn't happen in life. You do one mistake and do again, you'll end up in a bigger mistake. So don't do that again. Now, coming to the second part, if I have A matrix, then plus and then B and then transpose is there. Very simple, just open the transpose, A transpose plus B transpose, simple. If it is minus, it will be same thing, students. Okay. If we have A minus B whole transpose, that will be same thing as A transpose minus B transpose. Now coming to scalar multiplication and then transpose. Let's say we have Ka, you're multiplying a scalar K and to a matrix A and then doing a transpose. So that is equal to K and then transpose it first. So you can do the multiplication later. You can just transpose the matrix first and do the multiplication later, students. Now this is very important. A-B multiplication, whole transpose, very important for your KCET part also. Okay. So A-B whole transpose can be written as what? B transpose and A transpose. See here, the most important part, your B is coming first. A-B whole transpose in this, your B is coming first, students, and then A. Okay. So whatever is last, it comes first. So if we have three matrix A, B, C, then what will happen? If I'm doing a transpose, first the last one will come, then the second last, and then the first one. Okay. Same thing if A power N is there and then transpose is there. So what do you do? First do the transpose and then do the power N. Okay. If you have A power N and then transpose, so what do you do? First do the transpose and then do the power of it. Okay. Very simple and important for KCET. These three are very important. Now, same thing for the inverse, which we'll talk about a bit later. Just showing you the properties. AB whole inverse is nothing but equal to, first we'll get the B inverse, student, and then the A inverse. Okay. So very important. A lot of times students do mistakes in this. Don't do it. Now, if you have more than one matrix, okay, we have a combination of, let's say, A1, A2, dot, 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 till AN. We have n number of matrices and then transpose. So what we'll do? First, the last one, then the second last, like that, till A2 and then A1, the first one. Okay. Just reversal order will do. Okay. Whatever is in the last will come at the first. Any doubt, do put in the comment section along with the timestamp. Okay, or you can put it in the WhatsApp group. We'll try to make sure that your doubts are clarified in the doubt sessions. Okay. Now we have a matrix A is equal to 1, 2, 3 and 4, 5 and 6. Now here we have B is equal to 2, 1, 3 and 5, 4, 6. Now what they're trying to say is you have to verify all the properties. Okay, all the properties means whatever the properties we have listed here, you have to verify them. Okay, so what do you do? Pause the video, solve this one example. Okay, and if you have any doubt, put it in the comment section. In our solved video, we'll put this solution of this part. Okay, and if you don't need it, you can just skip it. Now students, overthinking that the pace of the crash is a bit slow, you can fast forward and you can watch the lectures. And for whom you're thinking it is a bit fast, you can just slow it down or stop it, the point where you're not understanding, again go back, again understand, and then come back. And the same, I won't be repeating again in the next video lectures. Do take a pen and a paper, write it down. Writing is most important, students, because it feeds the data in your muscle memory. In exam time, you might forget what you have understood or what you have like remembered, but if you do it by writing, it will remain in your brain like a muscle memory, and your hands will automatically write it down. Okay. Next, coming to the next section, very important topic, students, symmetric and skew symmetric. For the KCET exam purpose, a lot of questions are asked each year from this topic. Okay, so let's see. What is a symmetric matrix? Now the definition is pretty simple, students. The moment we understood what is a transpose, if the transpose of any matrix is equal to the same matrix, then we say it is symmetric. Means A of ij, if you change it to row and column also, will be equal to A of gi, we can directly say it is symmetric. Okay, nothing more than that. It is symmetric matrix. Okay, clear? Now, if we get what is skew symmetric? The skew symmetric is a bit different, not much difference is there, but the concept is almost similar. Skew symmetric is what? A transpose is equal to what? Minus A. Okay, here we have A transpose equal to just A, and here we have A transpose equal to minus A. Here A of ji is equal to what? Minus of A of ij. Okay, students, so nothing much difference, but only bigger differences. Don't take it like fully same. A transpose equal to A here, but it is symmetric. A transpose equal to minus A, it is skew symmetric. Okay, now one very important question, students. Can all square matrix is either a symmetric or a skew symmetric? If they give you a very small question, okay, that every square matrix out there in the world is either symmetric or skew symmetric. So what are you going to say? No. The answer is no. Why? Because there will be like matrix like 1, 2, 3, 4. It's a what? Square matrix, because number of rows, number of columns is same. Okay, but it is neither what? Symmetric nor skew symmetric. So there are matrices which are square matrix but neither symmetric nor skew symmetric. Okay, now one very important point here for a skew symmetric part. In a skew symmetric, all the diagonal elements of a skew symmetric matrices are 0. Now you'll say, sir, why is this? Okay, though maybe few people will know. So let's say, now in case of skew symmetric, we know what are the diagonal elements where I is equal to j. Now when A of ii is equal to minus of A of ii, so what are you going to do? Bring it both one side. So 2 of A of ii will be equal to 0. So A of ii will be equal to what? 0. So what you can see for the diagonal elements where I and j both are equal, they're equal to what? 0, students. So very important point. Do write it down, okay? And do make a note. And if you want, you can upload your notes. We can check and we can comment whether you're doing it good or not, or we can give you a few pointers on that. Now coming to an example, let's see. Let's see an example. We have a matrix A is equal to root 3, 2, 3, 2, minus 1.5, minus 1, 3, minus 1, 1. Now when we do the transpose, students, okay, you can see the rows we are changing it to columns. So this whole column we have taken and made it as one row. This whole second thing we have taken as a second column, we have made it as second row. And the third column we have made it as third row. Okay. So now understand it is what? A symmetric one. So we can see that A transpose is nothing but exactly equal to A, students. Okay. So when we interchange the rows and columns, we got the A only. So we can say directly it is symmetric. Okay, pretty simple. What is the concept? A transpose equal to A. Keep saying along with it. Okay, you'll learn very faster. Now, coming to the second, directly by seeing only we can see that the diagonal elements are 0 and these elements are E, F and G and these are minus of that. So if I transpose it, student, what will happen? These non-negatives will come here and the negative part will come here. So if I take a minus common, it will be exactly same as the matrix. So that is equal to A transpose is equal to minus A. So it is skew symmetric. Okay, very simple, clear, done. So this is the concept behind symmetric and skew symmetric. Let's see the properties from there. The questions are always asked in your KCET. Now let's see the properties important for KCET for any square matrix. Okay, A plus A transpose, always keep in mind it will be symmetric. Okay, A plus A transpose will always be symmetric. And if you do A minus A transpose, it will always be skew symmetric. So these formulas should be on your fingertips because a lot of questions will be asked directly and you can use them directly and solve and save your time. Okay, it will just take like 10 seconds and you will be done with the question. Now for any square matrix A, okay, understand every square matrix A can be written as part of symmetric and a part of skew symmetric. So very important, a lot of questions each year is asked in your PU also, in your PU board, those who are writing the PU boards, okay, this question is pretty common. And for the people for the KCT also, this is very important. Now, if we have two matrices and both are symmetric, if A and B both are symmetric, then what will happen? If AB is equal to BA, then it means that AB is symmetric. Okay. So understand, very important questions are directly asked from, what do you say, this part is there, this kind of questions are there in your exemplar also, students. Okay. This is a kind of short trick you need to keep that in your mind. Whenever they have given A and B are symmetric and they have given you that AB is equal to BA, you can directly say that AB is symmetric, students. Okay, or they can change it vice versa. A and B they can give you symmetric and they have told you that AB is also symmetric, so you can go to this. You can say that AB is equal to BA. Okay, now coming to the second part, the most important properties. If we have anything like B transpose A and B. Now we have three matrices. One is the in between, we have middle a different matrix, and then the starting and the ending we have B and B transpose. Now understand, in this case, the whole, whether this whole thing will be symmetric or not depends on which one, the middle A, the middle matrix A. If that middle matrix A is symmetric, it will be symmetric. If it is skew symmetric, it will be skew symmetric. So very important trick for your KCT. Okay. Now, if A is a symmetric matrix, then A power n can be symmetric if n is a integral numbers, positive integers like 1, 2, 3. Okay, clear? If A is a symmetric matrix, A power n will be symmetric, students, for all positive integral, or integers. Okay, integral means what? Integers, students. Now, if A is skew symmetric, A power n can be symmetric when n is even integer, positive even integer, and skew symmetric when n is odd even integer. So understand, if A is symmetric, A power n will always be what? Symmetric. If we have positive integers, A power n is skew symmetric, then it can be symmetric. Okay. Understand, student, if A is skew symmetric, then A power n will be symmetric if the value of n is positive even integer, like n equal to 2, 4, 6, 8. Now, if you say, sir, if A is skew symmetric, A power n, when it will be skew symmetric? If n is equal to what? 1, 3, 5. So what will happen if I know that A is skew symmetric? Okay, understand this part, very important. If A is skew symmetric and they have asked what is the value of A power 3. So directly we can say A power 3 will be what? Skew symmetric. You don't have to solve anything. I've made a shortcut here also. A power n whole transpose is nothing but A power n. Okay, and where n is even, then we get A power n minus of A power n where n is odd. So it will be symmetric if n is even. If it is odd, it will be skew symmetric. Okay. Now coming to the next, if a matrix is both symmetric and skew symmetric. This question has been asked a lot of times in your PU and KCT. If a matrix is both symmetric and skew symmetric, it always has to be a null matrix. Okay, clear? Now, if A is symmetric, student, okay, and B is also symmetric, and A and B are of same order, then this is a trick. AB minus BA, directly you can say skew symmetric. AB plus BA will be symmetric. A plus B will always be symmetric. So directly you can go through this. Okay. I'm not going on the derivations part since we are not teaching as of now for the PU part, students. So if you need derivations and other, we'll be bringing for the PU part a bit later. Okay, once the KCT is done. Now let's see the last part, inverse and the elementary row operations. What is basically an inverse of a matrix, student? If A is a square matrix, the first condition, A should be a square matrix. Order what? M. Now if there exists such other square matrix B of same order, such that AB is equal to BA and that is equal to I in terms of matrix, or 1 in terms of matrix, or a unit matrix, then we say that A is a inverse of B or B is a inverse of A. Both is true, okay? Don't say that only just if AB is equal to I and BA is also equal to I. So we can directly say from here is that A is equal to B inverse and B is equal to what? A inverse, student, okay? Pretty simple as it is. You can check it also. Let's say we have taken a matrix A, we have taken a matrix B, and we have multiplied them. So what we got? We got I. So we can directly say that B is inverse of A and A is inverse of B. Okay. Now, very important property here. If inverse of any square matrix, if it exists. So first thing is there is a condition we need to check whether it exists or not. Now, once we know that it exists, the matrix is unique. Okay. The inverse, it cannot be like it has 2 or 3 or more inverse. Okay. It will have only one unique inverse. Okay. Inverse of a square matrix, if it exists. Very important, students. It cannot exist also. If it is existing, then it is always unique. Okay. Coming to the next part, elementary row transformations. We have 3 things which we can do. 3 rules we need to follow. Okay. Very simple, basic 3 rules. Now, all the solved examples and PYQ will be coming separately on the PDF sheets that will be given in the description link or will be given in the along with in the WhatsApp group. So do join the WhatsApp group for the doubt sessions and for the PDFs also. Now, elementary transformation, friends. First thing what we can do, we can interchange any 2 row or column. What we can do, we can interchange any 2 row or column. Means row 1 can be interchanged with row 2. Okay. Or column 1 can be interchanged with column 2. Pretty simple. Now, any row or column can be multiplied by a non-zero scalar. You take a row 1 and then multiply with 2 times of row 1. That's simple. Or you take a column C2 and then multiply C2 into 5. Whatever you want, you can multiply. Okay. Now, any row or column can be multiplied by K. Now, any row or column can be multiplied by non-zero scalar. So, if we have row 1, that is will be equal to row 1 into 2. And if we have column 2, we can multiply column 2 into 5. Now, coming to the third point, students, very simple. We're just combining, this part and adding it up and telling you any row or column can be multiplied by K and can be added to any other row. Means, what we are doing is we are taking row 1 and we are writing that row 1 is equal to row 1 plus 2 times of some other row which you have multiplied, like let's say row 3. Okay, so we can do that. And same thing is applicable for column also. Let's say we have written column 2 is equal to column 2 plus 5 times of column 1. So we can do, so what we have done, we are adding column 2 with what? Another column, and in that column we have multiplied something. So we can multiply something to a column and add it to a column. Okay, so here we are doing 2 things, students. First we are multiplying something to a column and then we are adding to a column. Okay, now that sums up for the whole concept video and formula for the matrices part. We'll bringing it very soon, the determinants parts also. Okay, do spread, like, share and subscribe, and for any doubt section, for any doubts, do join the WhatsApp section, do join the WhatsApp group. Okay, and do comment if anything you have doubt in the video, including the timestamp. Okay.